Hello and welcome. We are going to take a look at my stamina and health system. Before we jump into the setup, initialization, profiling, and status effect stuff, I just want to show you the beauty of the optimization in the system because it's unmatched by anything out there and it's a steal to just have it listed for this kind of price. So we are going to spawn 200 of these actors ticking with the blood system, and they're going to have 51 status effects above status effect. So this is what we are going to spawn, the blood component, and when it's initialized, when it starts in the level, we are going to initialize it and we tell it, hey, you should start regenerating health. So it's going to be ticking with 51 status effects. 51 each. Each actor has 51 status effects. And let me show you the tick cost without it first. So right now, the inclusive average for tick time is 0.6, 0.7. Okay, and that's with pixel error running in the background. Now let's just hook this bad boy up and see how much it costs. Barely any difference. There's 0.15. That's ridiculous. I mean, I'm amazed by this myself. I spent like 3 weeks compressing the math as much as I can. And if you are a C++ programmer, I encourage you to dissect it, look into it, because you are not going to build any fuel system the same anymore. With that being said, let's jump into, before you call bullshit on this, all these tick actors are here. GVP tick 0 all the way to 200. They got the blood component in them with the tick active. So with that being said, let's jump into my project where we will take a look at initialization, profiling, and all that good stuff. Alright, so here I am in my player character blueprint. Let's go over each variable and both of the components together. We will cover everything. You won't have to go through the documentation on your own and read. So once you have added the Jeber Breath Pro component into your actor, you will need to go to the initialize category and configure these variables on your own. So the stamina regen delay multiplier, this is going to act as a base multiplier for the delay. So if this variable is 0, there's not going to be any delay. If it's 1, the delay will be normal, and the delay is set by the curve, this curve. And this curve is percentile based. So at time 1, it is 10. At time 0, it is 0. So if we have burned our stamina completely, we will have to wait 10 seconds to regenerate. Next is the walk speed. Now these variables, the walk speed and the crouch speed, they're there so they can so the component can identify when we are actually supposed to burn stamina. So they're not going to have internal functionality. They're just there to figure out if we are actually supposed to be burning stamina or not. The crouch speed is the same thing. We are not using it for internal functionality of setting the character movement component. It's there just to identify and return the correct variable, the correct speed variable. Morph multiplier. So the morph multiplier, that's for your morph target animation. If your character has a morph target that's supposed to be animated, I suggest putting this value to 0.5. And this variable will multiply your breathe morph curve. So this is just a basic curve from 0 to 1. It's just there to smooth out the setting of the morph animation. Stamina regen multiplier. This does exactly what it says. If it's 0, there is not going to be any regen for the stamina for the natural regeneration, but buffs and debuffs will still work regardless of this variable. And the regen multiplier will also multiply regen curve stamina, this curve. So this is a percentile based curve. So as you can see here, if we have burned no stamina at time 0.1, so we have burned 10% of our stamina, we will regenerate 0.9 per second, 0.994 per second. And you can see here, if we have burned 90% of our stamina, we will regenerate only 0.45 per second. Okay, we covered all of these. The character speed curve. So again, this is also a percentile based curve. This is the sprint speed of your character based on the stamina they have. So if we have burned 60% of our stamina, we will only be able to run at 420. If we have burned 90%, we can only run at 250. So the speed of the character will always be smooth and realistic. That covers all of the curves and the multiplier variables. The morph name stamina, pretty basic. That's the name of the morph target in your skeletal mesh. And the breathing data table. So let's take a look at this right now. So as you can see here, we have 5 rows in here. Each row is supposed to represent a state, a player state. And in each state, we have 6 different states that represent the breathing cycle. So if we are standing, we will fire specific SFX for that breathing. And you can also set the SFX for the amount burned. So if we have burned 80% of stamina, we will play a different SFX. So it's very realistic, and it's fully fledged. There's no more you can add to this which will make it realistic. Next up is the profiling, the max stamina and the agility. The max stamina, you can, modify this in runtime, which would scale up with something like, endurance perk. And the agility is supposed to be the variable which controls how much stamina you burn when you are sprinting. So if this is set at 0, the character will burn 1 point of stamina per second. If it's 0.1, it's going to burn 0.9 per second. If it's set to 1, if the agility is to 1, the character will burn no stamina when they are running. Okay, runtime, sprint bool. So you will need to integrate this. You will need to set this variable in your character blueprint. So in my movement logic, when I hit the shift key or whatever your key is for sprinting, we have to set the sprint bool on the breath component. So the component can know when we are running. And the breath of fall multiplier. This is actually not used anymore. So you can ignore this. I was supposed to delete this variable, but it stayed there after I changed the logic. I made it agnostic. And the allow breathing. So if there is supposed to be some cinematic effect or something where the player is not supposed to play the breathing SFX and the morph target animation, you set this to false. So that's what this bool is for. The player state. The player state is going to control what breath SFX you will play from the data table. Okay, that covers pretty much everything. I do want to go over a few things. I had it on here. So I'm setting my speed, the character speed, in my own custom way using KLS locomotion component. So this component is not going to set your speed for you. You're going to have to grab it and implement your own way of setting that speed. And it's pretty straightforward and simple. So you can use it with character movement component, any custom movement component. Next up is breath triggered. So rather than handling playing SFX inside the component, I made it so that the breath is populated into a variable and you can play it in your own way. Whether it's supposed to be UI, whether it's supposed to be played in multiplayer in a replicated manner for multiplayer projects, you will grab the new breath SFX variable and play it on your own. This will trigger every time breath is supposed to be drawn or exhaled. And this is perfect for also integrating VFX. I haven't integrated VFX into this yet, just haven't found the time, but this is how I would do it using this event. Alright, that pretty much sums it all up. Okay, so breath buff removed and breath debuff removed. So you will need these two events for when you want to remove, UI logic, whatever visual effects you have in your projects. And this will be triggered when the duration of the status effect runs out. And the same thing can be found in Blood Pro. And you also got your death trigger event in here. I haven't implemented a death logic with this component yet, but that's how I would do it using this. Not too sure why it took me to the footstep logic. Let's go back to this now. So I want to help you out with how you should handle implementing some kind of visuals in your UI for your status effects. So let's jump into this right now. If I actually remember when how I did this. Move status effect. Let me take a look at the designer. Okay, so it's a uniform grid panel, nothing too special about it, and the children of those grids. This is the logic behind them. Okay, yes. So each child will tick on its own, and I'm gonna get into this in a second. But let me show you this so you know how to set it up in your own UI. When you want to add a UI status effect, we want to find out if our DMI has been initialized or not. This is actually a custom material setup, so you can ignore this. Let's just pay attention to this and this. Total duration will be updated each time it's called. And then on the event tick, we will grab the debuff effects map and the buff effects map. We find it using the status effect name populated from here. Break JVP status effect and update status effect. So if we find it, we can update it. And I'm grabbing my own percentage here, and I believe the logic behind the percentage for finding out that the percentage is something like this. total duration. I believe that's how I'm doing it inside this variable, inside this function. And then I subtract it by 1, so I find out how much is left in total percentage. So that's going to help you create UI animated stuff for the status effects. And the same thing is happening for the breath system. Just one key thing is the debuff effects and the buff effects map. You grab it from the breath and the blood. That pretty much sums it all up. Let's go back into the manager. So the register debuff UI and the register buff UI. So this is a function right here. We are trying to update it if it's already in there. If it was not updated, we will create it from scratch and we will add the UI status effect. And we add child to uniform grid. This logic is not perfect for the grid, but this and this is the best. Let's take a look at this one on how you would update it. We do a pure cast towards the child status effect. And if it's matched with the status effect populated from here, we set the local variable to true, and we update it again with the new total duration status and the status effect name. And this is the same logic as this. There is no difference. And these events are being called from the player character. Remove buff status UI and remove the buff status UI, and also when we are adding it. Where did I put it? Oh yes, consumables graph. We are in the consumables graph. Oh, here it is. Health syringe used. Yeah. It's a dizzying mess when you're juggling multiple things and wearing different hats. So cut me a break. Yeah, stamina syringe used and health syringe used. First, we add the buff effect, or however you want to call it. But after you add the buff effect, that's when you register it in your UI. So the variable will be updated, the map variable will be updated correctly. Okay, that's all there is to it. I hope I covered everything. Let me just go over my notes real quickly, make sure that... Okay, yes, there is one thing I missed. Where did I put it? The net health change rate, the total change rate per second. So net health rate per second. So this variable, as small as it looks like, it's pretty important, and it gives you that element of high quality polished AAA logic in your project. This will display the total change that's happening in the stamina or the blood. So it's going to calculate the buffs, debuffs, natural regeneration, all of it, all together, and it's going to return it and show it to the player. And that's very important for skill-based games like Dota 2, League of Legends. If you don't have this variable in those kind of projects, you're kind of visualizing the bar. You're looking at the bar and saying, oh, am I going to have enough stamina if I come back a minute here later to cast that spell or whatever? Actually, they don't have stamina in Dota 2 or League of Legends. That's freaking mana. And where did I handle all of that? Self status, yeah. Vigor stats. Okay, here's where I'm handling it. So I first rounded to 1 decimal point, so it looks nice for the player. There's not like, the value is not going to be 1.0000000. It's going to be 1.0 only. So I rounded to 1 decimal and I appended to /s. And that's all I'm doing here. Okay, that's everything. And I hope this will be of use to you in your project. If you have any suggestions or something like that, please let me know. Drop a comment in the video. I will be integrating this for real-time simulation projects, which will be absolutely amazing. I will have a plan in mind for it. It's just I don't really have the time to do it, but I will have enough time at the end of the year. So with that being said, I will see you on the next masterpiece.